Hi, I'm Chris from Simmel, and today I have a tutorial covering blueprint usage with trueSKY and Unreal Engine 4. I'll be going over how to use the blueprints in conjunction with event triggers to dynamically set the weather and to set the atmosphere effects, as well as some of the water settings. I will be using trigger boxes, so this will be perfect to set up biomes and having different effects depending on the biome or location within your game world. As with most of my tutorials, these can be expanded upon pretty easily, and I'll be aiming to cover the main functionality, and hopefully that will unlock the potential for you to push further in your own projects and to have it as a use case for different scenarios. So, for example, rather than using trigger boxes, you could use other events such as specific time of day or switches within your level, so if a certain event happens, a certain cloud system will occur. I will be assuming within this tutorial that you have a base level understanding of Unreal and trueSKY. If you do not and you are completely new, to avoid getting lost, feel free to check out some of the other tutorial videos on the channel, which will cover most of the functionality of trueSKY, and then you should be able to return here and be able to keep up. Within this tutorial I have two levels set up. Both of them are pretty much the same, just one is a simpler version which I will use to explain the theory behind this setup, as well as explain some of the functionality of trueSKY specific blueprints. And then the second level I have will showcase what will happen if I push the blueprint past its basic setup and show how many variations and variables I can alter at once using this system. So this level setup is fairly simple. I have 4 trigger boxes, as you can see here, which I will be using to trigger which biome the user is in. And just for visual clarity, I've added some basic meshes in there, so one marking a desert biome, one for an open plains, one showing a mountain, and another one for an ocean, which I have true water in currently. And then I've got anything outside of this marked as neutral or default. I also have a slightly different looking sequence than you're probably used to seeing. I have opted to set a keyframe for both the sky and cloud layer upon every hour within the timeline. This is because I'll be setting what is within these keyframes via blueprints, and so having one to reference every hour will give me a good framework to work with so that my updates will happen quickly but not instantaneously. But I'll explain that further as we get on to looking into the blueprints. I've also tweaked a few settings within the sequence actor and the trueSKY light, but nothing too extreme. The notables are that I've increased my progression scale so that we have automatic time passing, upped the cloud resolution slightly, added a small amount of wind speed which gives me a bit of churn on the clouds which will make interpolation look slightly smoother, increased my cloud steps, my edge noise texture, and lowered my amortization of the atmospherics and the amortization on the clouds themselves. Everything else is left at default. Now that I've covered how my setup looks, I'll head on over to the blueprints themselves. I have done this blueprint within the level blueprint, and as you can see it is not too large of a blueprint setup. This is only changing the cloudiness variable within this scene, as that is the easiest to visualize and will allow me to go through it in more detail but cover what each of these nodes are doing. I'll start at the top as that is the most logical thing, and I have set an event begin play. This is essentially just going to set me defaults and grab me default values which I will store for use later. I will also mention now, and will probably mention later as well, that I have a set of booleans here which you'll see dotted around the blueprint. These don't actually do anything for this blueprint, it was just as a visual aid, as when we get onto trigger box overlaps and such, I realized that just them being called trigger box will not be the clearest thing, and so I set up a boolean which is desert biome, ocean biome, so you know which trigger box I am referencing when I am setting values. So upon begin play, you can see that I just ensure that all of these booleans are set to off, and then I start immediately using some of trueSKY's nodes, and I will explain what each of these do now. So the first one we have is to get the cloud layer unique identity by index. This allows me to get what the active sequence is within the sequence actor. So if I go to my sequence actor in my scene, we have biome testing, which is this sequencer. And I chose index 0, which will grab just this layer here, and it will return that unique ID, so that when in the next node I want to grab the ID of a keyframe, it will know that I am referencing keyframes within this layer. If you have multiple layers, which is very doable, just becomes slightly more complex, so I haven't set up for this example, you will see that it has a different unique ID, and this will mean that if I create another keyframe, I can use this node and set my index to 1, and it will grab this next layer, which is cloud layer 205, and then it will know that the next keyframe within that layer, the next keyframe I will be looking for in that layer, not the layer above. So we loosely touched upon this node already, which is the get next modifiable cloud keyframe unique ID. This does as you would expect. We get the cloud layer and then we find out what time we are on the timeline and then get the next keyframe that is coming up. And so, for example, if I am, say, at 13 minutes past 7, the next keyframe will be the one at 8 AM, and we will get the unique ID number here, and this applies to everywhere. So if it's 15 minutes past 10, it will get the next one in the timeline, which will be the 11 AM one, which will be unique ID 71. What this allows us to do is to take the unique ID and use it to either get or set the next value, and then as time progresses we will then interpolate to this new value from what we were before, and this is what this blueprint is built upon. So on the begin play, we're getting the ID of the layer, getting the ID of the next keyframe once we press start, and then I'm just using it to set the default, which is a variable that I'm using to just store the values so that we have a default if we ever need to revert to it, say if we leave a biome and there's not a new biome assigned. And then I'm setting the next cloud keyframe so that when we start the level, we are guaranteed to be on the default cloudiness, which on all of these cloud keyframes, all of the settings are left on default. So that's just the on play. The meat of this blueprint and what makes it work is this event tick setup I have. You can probably use a different setup rather than event tick, as obviously event tick comes with higher costs, and this doesn't actually need to be checked every single frame. It only really needs to be checked every hour in game, but this will depend on how you've got your sequencer set up. But for this example, for simplicity, I've gone for event tick, so it's always being checked. We have a very similar setup where we are getting the layer and the next modifiable keyframe, but rather than getting the value and then setting it, we are setting the cloud keyframe value to what I have called the next keyframe's cloudiness. This is a good point for me to explain my variables to you. So for each of the keyframe values, I will set a default of that value, so the default cloudiness variable, as you can see here. And then I will also have a second one, which is the next keyframe cloudiness. And then I'd have these two variables for each setting, but as we're only covering cloudiness, I will only be showing that. And so the intention of these is that the default cloudiness will essentially be a stored value from the begin play if I ever need to return to it, which I do when I stop overlapping. And the next keyframe cloudiness is the one that is changed, and that every single tick we will be setting to a value depending on where we are. And then I also have a print string here just so that we can visualize these changes as they happen. So since most of the power and functionality is actually done through this event tick, I go to the overlap settings, which as you see upon beginning overlap, I will use these booleans to show which biome I'm in. So if I'm in the desert biome, I will be setting the next keyframe's cloudiness to 0, so there will be no cloud coverage. And then for the ocean and the open plains, I've got it to be slightly less than default. And in the mountain biome, the cloudiness will be more overcast. And so as you enter a biome, you will set the next cloudiness keyframe, which will then change the cloudiness. And then as time interpolates to that keyframe, the cloudiness will occur. And then finally, we have, upon ending overlap, again, the booleans are irrelevant, but then I'm just setting the next keyframe to the default value, so that if I'm not in a biome, I'm back to defaults. And I will show this functioning now. If I press play, as you can see, we're pumping out 0.6 while we're in the neutral areas, as this is the default. If I head to the desert biome, you will notice it drops to 0, but the cloud does not update instantly. And then as we interpolate towards the hour, the values decrease. So if I leave here back to 0.6, there is a delay while the keyframes are being interpolated to, and then the clouds return. Head to 0.7 and the clouds, well, head to the mountain biome and the clouds should become slightly thicker and more overcast. Hop to the ocean and they will become smaller. As mentioned earlier, I do have a more complex and fuller version of this setup, but before I head on over to that, I will show how to set and get these values if you don't want to work with the cloud keyframes. So for example, if we are wanting to, instead of setting cloud keyframes, do some of the sky layer, which is something that we can very much do, and control the sky keyframes and sky layer, we actually have a get next modifiable sky keyframe, which works exactly the same as the get next modifiable cloud keyframe, however does not require a unique ID for the layer, as there can only ever be one sky layer. We can feed this straight into a set sky layer value, which works identically as the set cloud keyframe value. Again, this has all of these variables exposed as you would find on the actual keyframes themselves, so you would have the same amount of control over this. With 4.2a's latest update, we also have the ability to set the water variables and have them change at runtime. In order to do this, you need to get a water object, drag from it, and if you just type water, you will be able to see the set water float, int, and vectors. Most of the settings are actually within the water float, and as you can see, we can set the Buford scale, wind speed, wind direction, dependency, and all of the settings within the trueSKY water actor, and have these change at runtime. So for example, if you've got a, say, ocean game, and you want it to become more stormy and the sea to become rougher as the clouds get thicker overhead, this is something you can now do, but I will cover that in a different video at a later time. So moving on to a more full example, I'll head on over to the next level. As you can see, it is identical in setup. I have the 4 bounding boxes. I have my meshes representing the different biomes. The only thing different here is this static mesh, which I use to keep track of what level I'm in. However, the blueprint is much more robust and much larger, as well as a wider selection of variables. This is because all I've done is I've taken that basic simple setup from the start and I have duplicated it for each of the settings within the keyframes. And so as you can see, I start here with cloudiness, but then I also grab my cloud base, my cloud width, my cloud height, my upper layer strength, I've attempted to organize this in such a way that they are in groups for each of the sections of the sequence itself. So as you can see, it's separate into main, shape, noise, precipitation. I've tried to comply to that formation. And for each one of these, I just set 2 variables, which is the default and the next one, the next keyframe value. And then again, I'm using the same setup for setting the values, just pumping the next keyframe cloudiness in. However, most of the work done by this blueprint is within the overlap set values. So when you overlap one of the biomes, these are the settings that we will be changing to. So I have my cloudiness values from the last one, and then most of these I have left at default, just due to time constraints while setting it up. However, just to show some of the functionality, I have set up some precipitation changes, such as the next keyframe for rain and snow while in the mountain biomes. I will point out at this moment that you can get actors from the sequence actor itself and set them in a very similar way. In order to do that, much like the water, you can drag in the sequence actor itself, and then if you just search for what they are, so I'm looking for precipitation settings or rain, as you can see, you can set the raindrop size and raindrop fall speed here, and it will just get the variables as they're exposed within the sequence actor themselves. Anyhow, let's show this functioning. So as you can see, default is the same as before. If I head on into the desert biome, we will see a delay before it starts to clear up as we run to the next keyframe. Then going directly from this desert into the mountain biome, we will actually see the clouds start to build up and then the rain to come in and then start snowing. Then leaving from this one into the defaults, the snow will clear up. And then head into the ocean biome. Finally, just to show the clouds are functioning as expected. So I'll do one final run through of how this works. Is that on begin play, I get the values and set a default. Then upon overlapping, I will change the next keyframe's cloudiness variable or next keyframe's variable and set it, and then feed it through each tick into the keyframe, the next keyframe, so that as time progresses, we will interpolate using the sequencer to the newer value. If we get many requests, I will potentially release these blueprints in a pastebin format for people to grab. So if you've not managed to follow along and would like to be able to download these, just leave a comment and I will see if there's a demand at making these slightly cleaner and then give a pastebin for users. As always, I'm excited to see how people use and implement this within their projects. So make sure that when you're showing your project or showing screenshots, to use the hashtag trueSKY on all of our main social media channels. Head on over to the Q&A channel within simul.co with any questions you have about the plugin, or potentially suggest other video ideas and for general discussion. Or leave a like and a comment on this video. This video was actually inspired by a comment from a user, so I do listen and I will try and make videos if there is demand for them. I hope you all have a good day.